go with our lesson for 6.4, factoring polynomials. Okay, we're going to focus on two learning targets in section 6.4. We're going to learn how to factor using a greatest common factor and a difference of squares. The first problem here, greatest common factor, we look at the terms 12x squared y and 16x cubed y squared, and we're going to start with the numbers 12 and 16. The number 4 is the greatest common factor which divides each of those numbers. So we write it down and we put a group of parentheses, and we're going to determine what's going to be left over here. When we look at the x terms, we have an x squared and an x cubed. We are going to take the smaller of the two exponents and pull that out, x squared. Now we compare the y's. Those variables, we have a y and a y squared. Again, the smaller exponent is the y. So we are going to factor out a 4x squared y. We have a minus sign in between. We must bring that down into our grouping as a minus. And now we are going to determine what's left over in the parentheses by doing some division. Factoring is division. 12x squared y, if we take out a 4x squared y, leaves us with a 3. So our first term, when we factor, has a 3 left in our parentheses. Now we're going to take the 16x cubed y squared and divide that by our greatest common factor, 4x squared y. To show this division, or this factoring, I'm going to write out the terms and see what we can divide out. So 16 divides by 4. We can divide out 2 x's and 1 y, and we're left with 4xy. So in the parentheses we put 4xy, and we have completed our problem. Our greatest common factor is in front of the parentheses, and our 3 minus 4xy is inside the parentheses. We can always check with the distributive property. Our next example, if we look at it, has 3 terms. Our numbers are 15, 20, and negative 10. We can pull a 5 out from all of those. So if we write down the 5, we know we're going to have a plus and a minus in our grouping. We need 3 terms left. So we are going to look at the m variable to start with. M cubed, m, and m squared. Squared, a 1 and a 3, we always factor out the lowest. That's an m. So when you're looking at variables, you always want to look at the lowest exponent is what is factored out. We have an n squared, and an n, so we're going to pull out the end of the first. Now, factoring out a greatest common factor is like dividing, so I'm going to take the 15m cubed n and divide it by 5mn. We're going to have 3m squared left over. Now we take the 20mn squared and divide that by 5mn. We have a 4 and an n left if we divide out our terms. Finally, we are going to take the 10m squared n and divide that by our 5mn. That's a 2 and that's an m. So we have completed our factoring, and that is factoring using a greatest common factor. A new strategy called a difference of squares. We recognize these problems. First of all, they only have 2 terms. Notice these 3 examples have 3 terms. They contain a difference, right? They're all subtraction. They are differences. And finally, when we look at both terms, the first example, 25x squared minus 81, we have the difference, but we are also going to notice that the first term is 5x to the second, and the second term is 9 to the second. It's a difference of 2 things squared. It is a very fast factoring method. once I know it's a difference of squares, I take the square roots, which are 5x and 9, and put them into the binomials, and we finish our factoring by taking a plus and a minus in each binomial. Alright, moving on to the second example. Again, we start out by determining if we have a difference of squares. There's the difference in between the numbers, and now, can we figure out if these have square roots? Sure. 4y to the second squared and 25 squared. We have a difference of squares. So our rule is write down two binomials, place those square roots in the binomials, 4y squared minus 25 and 4y squared plus 25. Most students would stop here. However, I wanted to do an example that points out you must factor completely. Notice that first binomial is another difference, and it's a difference of two squareds again. So we can repeat the process, right? It's a difference of two squares. So 2y to the second and 5 to the second. That's a difference of squares. Notice our second binomial is addition, so it is not a difference of squares. That binomial will remain unchanged, but I can still break the first binomial into two parts. Okay, the second binomial remains unchanged. Now we can use our rule for difference of squares and take 2y plus 5 and 2y minus 5, and we also have the 4y squared plus 25. Excellent. Alright, our last example. Notice it is a difference, okay? 18x squared minus 32. Okay, let's give ourselves a little more room first. Alright, here we go. Now, I'm thinking this is going to be a difference of squares, but wait. I'm not sure 18 has a square root or 32 has a square root. It's not a difference of squares. Maybe there's a different method, like, greatest common factor first. I know that the number 2 goes into 18 and 32. So I'm going to pull out a 2 and divide both of those by 2 to get 9x squared minus 16. Now, with our number sense, we see, oh wow, I now have a difference of two square numbers. So we're going to go back to a difference of squares, 3x to the second and 4 to the second. We have a difference of squares, so I can break that into two binomials. Remember, a difference of squares can be written as the square roots added and the square roots subtracted. So I need the 2 multiplied in front. I'm going to have 3x plus 4. And I'm also going to have 3x minus 4. Outstanding. There we go. Those are factored completely is the key. We can always check with the distributive property on any of these problems and multiply them out to see if we're right. So, our factoring so far gives us somewhat of a factoring flowchart. Okay, and this is kind of a decision-making process. How should I think about my factoring? Okay, the first thing you always want to look for is a greatest common factor. Okay, once you have that, then you're going to break off and decide, do I have 2 terms or 3 terms in my problem? If I have 2 terms, the first thing I'm going to look for after a greatest common factor is that difference of squares. And then I can break it into 2 binomials, a plus b, a minus b. Awesome. Okay, That will only work if you start out with two terms, a binomial. Moving forward tomorrow, we'll deal with what happens if we have three terms, or a trinomial. That's our lesson for today.